It's been about 50 years since we last set foot on the moon. But now, humanity is going back. And this isn't just about repeating the past. Oh no, this is a massive leap forward, with the goal of building a permanent presence way out there in deep space. So, what's the plan? Let's break it all down.
So here's what we're going to cover. First, we'll look at how we got from the quick visits of the Apollo era to today's super ambitious plan. Then, we'll dive into the Artemis program itself, explore the first missions to the lunar South Pole, see how a permanent base is actually going to be built, and finally, understand why the moon is so crucial for our journey to Mars and beyond.
All right, first up, let's get our heads around why this new era of lunar exploration is just so different from everything that came before it.
You see, the entire goal has shifted. The Apollo missions, they were incredible, don't get me wrong. They were all about getting there, planting a flag and getting home. But the Artemis era is about something way bigger. It's about planting roots. It's about learning how to actually live and work on another world for the long haul.
We all know those famous words from Neil Armstrong. They marked the absolute peak of the first space race. But after the very last Apollo mission in 1972, a really long pause in moon exploration began. Well, that half-century hold is finally over.
So, how are we going to get there? What's the plan? Well, this brings us to the Artemis program, which is NASA's blueprint for returning humans to the lunar surface.
And the name itself is pretty cool and very significant. In Greek mythology, Artemis was Apollo's twin sister. And the program has two huge goals. First, set up a sustainable human presence on the moon. And second, use all that experience to get ready for the next giant leap, sending astronauts to Mars.
Now, to do this, you need some seriously powerful hardware. We're talking about the Space Launch System, or SLS. It's the most powerful rocket NASA has ever built, period. It's designed to launch the Orion capsule, the ship that will carry the crew far beyond low Earth orbit, deeper into space than any human has ever gone before.
So how does a grand vision like this actually unfold? Well, you don't just jump straight to building a moon base, right? It's all broken down into a series of very carefully planned, step-by-step missions.
And the great news is, the program's already underway. Artemis 1 was a successful test flight with no crew back in 2022. Next up, in 2025, Artemis 2 is going to send a crew on a flyby of the moon, which will set a new record for the farthest humans have ever traveled from Earth. And then, the big one. In 2026, Artemis 3 will be the moment we've all been waiting for, the first human landing on the moon in over 50 years.
Okay, so you might be wondering, why the South Pole? I mean, we've been to the moon before, but this landing site is completely new territory for humans. What's so special about it?
The choice of the South Pole really shows you the new strategy. It's so important because it has these permanently shadowed craters where sunlight literally never reaches. And scientists have confirmed these dark, frozen craters are packed with resources. Most importantly, huge deposits of water ice. That discovery is the absolute game changer that's powering this entire new push to the moon.
And all of this brings us to the long-term plan, building the Artemis base camp. And this time, NASA is not doing it alone. You could say it really takes a village. See, the modern approach relies on these public-private partnerships. This model means you can share costs and innovate much faster than the old government-only way of doing things during the Apollo era. For Artemis 3, for example, astronauts will actually meet up with a lunar lander developed by SpaceX. And companies like Intuitive Machines are already sending robotic landers to drop off science and tech before the humans even get there.
And what's really cool is that these partnerships show how solving challenges in space leads to innovation right back here on Earth. Take this. The Intuitive Machines lander was insulated with Columbia's OmniHeat Infinity fabric. This tech was directly inspired by those reflective NASA space blankets. It uses a pattern of little metallic dots to reflect an object's own body heat back at it, which keeps it warm without needing bulky layers.
And believe me, that protection is absolutely crucial. In space, temperatures can swing wildly from minus 250 degrees all the way up to plus 250 degrees Fahrenheit. So, the same lightweight, reflective material that keeps you warm in a jacket on a cold day helped protect critical parts on a lunar lander's journey to the moon. How cool is that?
Now, besides the missions on the surface, NASA and its partners are building something called the Gateway. The best way to think about it is like the International Space Station, but instead of orbiting the Earth, it's going to orbit the moon. It will be a vital hub for science, for communications, and a docking port for missions heading down to the lunar surface or, eventually, even further out into the solar system.
And that right there leads us to the ultimate goal. It's all about seeing the moon not as a final stop, but as a starting point for everything that comes next.
So if you take one thing away from this, it's this. The Artemis program is designed to use the moon as a stepping stone. It's a proving ground. It's a place to test technologies and learn how to be self-sufficient far from home, all to prepare for sending humans to Mars.
And this is where those resources at the South Pole become a true game changer. Water ice, well, obviously you can use it for drinking water and breathable air, but crucially, you can also split it into hydrogen and oxygen, which are the main ingredients of rocket propellant. The ability to basically refuel on the moon could make deep space travel so much more feasible. And beyond that, there's even potential to mine something called helium-3, a rare isotope that could be a clean, powerful fuel for the fusion reactors of the future.
And there's a real roadmap for how we get there. The plan for the 2030s includes a lunar cruiser for long exploration trips. That'll be followed by a foundational habitat on the surface, which will allow for missions that last for months at a time. And the ultimate goal? To have year-long crews rotating in and out, creating the very first truly permanent human outpost on another world.
So, while timelines can always change, the journey has begun. The Artemis missions are laying the foundation for a future that, honestly, used to feel like pure science fiction. It leaves us with this incredible question. When we look up at the night sky in 2040, are we actually going to be able to see the lights of a human village looking back at us?